In this real Cisco demonstration lab, I'm going to explain to you how to use and understand Traceroute to fix network connectivity problem. If you have seen my video how to use ping for network troubleshooting, you can skip first few minutes of this video. But if you haven't seen that video, it's not a problem. I'm going to give a brief intro here. So in this video, we are going to ping PC2 from PC1. You can see I'm pinging PC2 from PC1. The ping is timing out, but I'm going to ping the PC2 from R1. That is going to work. So that explained to us PC2 has a route back to 10.10.20.0.24 where we sourced our ping from router 1. But if you source the ping from 10.10.10/24 network, PC2 don't have the route back to PC1. So we are going to fix this by using Traceroute. So let's do a Traceroute from PC2 to R1, Traceroute 10.10.20.1. You can see the Traceroute complete successfully. Let's do the same thing to 10.10.10.1, and you can see even the first Traceroute is failing. So let's understand how Traceroute works. Say this is the PC we are pinging from, and it is sending a packet to our destination PC2 here. This is PC1, this is PC2. PC1 will send a UDP packet to the first router with TTL value of 1. And the first router will reduce the TTL to 0 and send back the response. And the PC will make note of the router IP address and send another request with TTL value of 2. So this will reduce the TTL by 1 and send the request to the next router with a TTL value of 1. This will reduce the TTL to 0 and send back the IP address of this router to this PC in its response. And the process continues until it reaches its destination. And you will get maximum of 30 hop results in your TTL if you cannot reach the destination host. So you can see our Traceroute has completed, and you can see maximum of 30 hop. And we could not see any successful Traceroute. And none of the routers has responded to our Traceroute request. And all 30 of them are failed. So that means even it is failing at the first hop, which is R4. So R4 does not know how to route the packet to any of the other router in the path towards PC1. So let's go and look at R4 routing table. Enable show IP route. First, we are going to look at the IP route for the default gateway, which is 10.10.50.1. That is the default gateway for PC2, and you have a route which is ETH01. That is this interface. So now let's check the route to 10.10.20.1, and you have a route for that network also via ETH00, which is this way. And let's check for the last network, which is 10.10.10.1, subnet not in table. So that means we do not have the route for it. So if you want R4 router to get this route, So let's look at what is the routing protocol used by R4. Show IP route. It is using OSPF. So if you want R4 to learn this network, you need to advertise that network into R1 routing table. So let's go to R1, show IP route, and you can see in the OSPF, you are not advertising 10.10.10.1 network. So show IP OSPF, and we are using process ID 1, router OSPF 1, network 10.10.10.0.0.0.255. That's a wildcard mask into area 0. Now let's go to R4 and see whether we have route for this network. Sure, we do have the route learned by R4 now. So now go to PC1 and do the ping. You will lose the first ping for ARP, and now the ping is successful. If you do second time, you will get 100% success. So this is how you use Traceroute to determine where the problem exists and troubleshoot network connectivity problem. Hope this video is helpful for you. If you like this video, give me a thumbs up. Also, please consider subscribing to the channel and turn on the notification for my future video updates.